We all know the Tropic of Cancer, right? That line on the map seems pretty simple. But what if it's, I don't know, more than just a line? What if it's dynamic and moving and has this whole history and even geopolitical weight?
That's exactly what we're digging into today. It's way more complex than just a mark on a globe.
Okay.
We're going to unpack it, the science, the name, why it actually shifts around, and the amazing range of places and life it touches.
So the mission is basically to take this abstract line and make it, well, real, a journey.
Precisely. Because understanding it better helps us see the planet maybe a little differently.
Yeah, I'm intrigued. Get ready for some maybe some aha moments, because we're going to see why this line isn't just for map makers. It matters to astronomers, pilots, even defense planners.
It really does.
Okay, so let's start with the basics, but maybe dig a bit deeper than school geography. What exactly defines where the Tropic of Cancer is?
Okay, so fundamentally, it's the northernmost latitude on Earth where the sun can appear directly overhead, like straight up, 90 degrees.
Directly overhead.
Right. And that only happens once a year on the June solstice. That's when the northern hemisphere is tilted most directly towards the sun.
So it marks the edge of the tropics, basically.
Exactly. The northern boundary, anything north of it, the sun is never quite directly overhead, even at its highest point.
And it's got a partner down south, doesn't it?
It does. The Tropic of Capricorn in the southern hemisphere. They're twins, in a way.
Oh.
And they're part of those 5 really key latitude lines. You've got the equator, the 2 tropics, and then the Arctic and Antarctic circles. They kind of frame the whole planet's climate zones.
Right, right. But what determines the exact spot? Why that specific angle around 23.5 degrees? It always seemed a bit random.
Yeah, it seems random, but it's pure astronomy. It all comes down to the tilt of the Earth's axis.
The tilt, okay.
Our planet doesn't spin perfectly upright as it orbits the sun, right? It's tilted over by about 23.4 degrees relative to its orbital plane. And that tilt angle is precisely what defines how far north and south the sun's direct rays can reach. That defines the tropics. If there were no tilt, the sun would always be directly over the equator.
Okay, that makes sense. The tilt causes the seasons, and it also sets the boundaries for the tropics.
You got it.
Now, here's something I've always wondered about the name. Tropic. Okay, I can kind of see that, like turning, the sun turns back south after the solstice, right?
Exactly. Tropic comes from the Greek word trop, which means turn or inclination. It refers to that point where the sun appears to stop moving northward and turn back southward in the sky.
But Cancer, the crab constellation, what's the connection there? That seems, well, odd.
It does seem odd now, but it's a fascinating piece of history. It's like a little time capsule in a name.
A time capsule? How so?
Well, so when this line was named, thousands of years ago, back in centuries BCE, at the moment of the June solstice, if you looked up at the sun's position against the background stars, which you shouldn't do directly, obviously, but astronomically speaking, the sun was located within the boundaries of the constellation Cancer.
So it literally pointed to Cancer in the sky at that key moment?
Precisely. So the name made perfect sense then.
But you said was. Emphasis on the was.
Exactly. That's the kicker. It's not in Cancer anymore.
Really? So where is it now?
Now, during the June solstice, the sun is actually in the constellation Taurus.
Taurus. So the name is completely out of date, astronomically speaking.
Pretty much. It's because of something called the precession of the equinoxes.
Okay, precession. Sounds complicated.
It's basically a very slow wobble in the Earth's axis, like a spinning top slowing down. It takes about 26,000 years to complete one wobble cycle.
Wow.
And over millennia, that wobble has caused the apparent position of the solstices and equinoxes against the background stars to drift. So the name Tropic of Cancer is stuck in the past, reflecting the sky from over 2,000 years ago.
That's actually amazing. A name that's outlived its own astronomical accuracy. That's a great aha moment right there.
Isn't it? Makes you think about other labels we use.
Totally. And speaking of things not being fixed, I always picture these lines, you know, the tropics, the equator, as totally static on maps, like they're drawn on permanently.
Yeah.
But you mentioned earlier it moves. The Tropic of Cancer isn't actually fixed.
That's right. Challenging that mental image is key. It's definitely not fixed. Its latitude is constantly, albeit slowly, changing.
So why? If the tilt defined it, does the tilt itself change?
Yes, exactly. There are 2 main drivers. One is that precession wobble we just talked about.
Okay.
And the other is a long-term variation in the amount of the axial tilt itself. It's not always exactly 23.4 degrees.
Oh, interesting. It varies.
Yeah, over a very long cycle, about 41,000 years, the tilt actually oscillates. It swings back and forth between roughly 22.1 degrees and 24.5 degrees.
41,000 years.
Okay.
So these are huge timescales we're talking about.
Immense timescales.
Yeah.
But because the tilt is constantly changing, even subtly, the lines defined by that tilt the tropics and the polar circles have to move too.
So what's the current situation? How fast is it moving right now? Is it noticeable?
Well, noticeable depends on your tools, I guess. As of the year 2000, the tilt was about 23.4 degrees, and the Tropic of Cancer is currently drifting south.
Southward. Okay. By how much?
By almost half an arcsecond of latitude per year.
That sounds many, all right.
An arcsecond is 3/600th of a degree.
Yeah, sounds minuscule.
But that tiny angle translates to roughly 15 meters or about 49 feet on the ground every single year.
Wait, 49 feet, 15 meters a year. That's actually quite a lot. You could measure that easily.
You definitely could. Over a decade, that's 150 meters. Over a lifetime, it shifted significantly.
So does that have practical implications? Like, are old maps wrong?
Yeah.
Or those roadside markers you sometimes see?
It absolutely does. For really precise work, yes, you need updated coordinates. And those markers, think about it, a marker put up 50 or 100 years ago.
It's in the wrong place now.
Yeah.
Significantly so.
Exactly. For example, they know it was precisely at 23 degrees 27 minutes north back in 1917. But by 2045, it's projected to be at 23 degrees 26 minutes north. That shift is real, and any physical marker becomes a historical snapshot, not a current pinpoint.
That really drives home how dynamic the Earth is,
Yeah.
even in ways we think are fixed. What about the Tropic of Capricorn down south? Is it drifting too?
Yes, it moves in lockstep. As the tilt changes, both tropics shift and the Arctic and Antarctic circles shift as well.
Ah, okay.
So the Tropic of Cancer drifts south, the Arctic Circle drifts north, and the Tropic of Capricorn drifts north, the Antarctic Circle drifts south. They all move together.
So the distance between them stays pretty much the same, the width of the tropical zone.
Essentially constant, yes. It's all tied to that single variable, the axial tilt.
Fascinating stuff. Okay, so we know what it is, why it's named what it is, and that it's surprisingly mobile. Let's talk about the where. What kind of world does this shifting line actually pass through?
Geographically, it's a really significant boundary. Like we said, north of it are the subtropics and the North Temperate Zone. South of it, down to the Tropic of Capricorn, is the region simply called the tropics.
And a lot of people live north of it, right?
An incredible number. Back in 2000, data showed that over half the world's population lived north of the Tropic of Cancer, which might be surprising given the huge populations in tropical countries like India, Indonesia, Brazil.
Yeah, that is surprising. So it divides more than just climate zones.
In a way, yes. And if you were standing right on the line, you'd notice the daylight hours changing quite a bit through the year.
How so?
Well, at the summer solstice June, you'd get about 13 hours and 35 minutes of daylight. Longest day.
Makes sense.
But come the winter solstice in December, it drops down to only about 10 hours and 41 minutes. That contrast really shows the tilt in action.
Okay, let's take that trip. Let's circumnavigate along the Tropic of Cancer. It hits 17 countries, you said, and several water bodies. Where does it start, say, from the prime meridian eastward?
Okay, starting from the prime meridian in Africa, it cuts right into Algeria, then Niger, Libya. It even just nicks the northernmost tip of Chad, very remote desert areas mostly.
Well, Sahara, basically.
A huge chunk of the Sahara, yes. Then it crosses into Egypt, famously going right through Lake Nasser.
The big man-made lake.
That's the one. Further west from the start, it also crosses Western Sahara, that disputed territory, then Mauritania and Mali. Still largely Saharan landscapes.
So Africa is dominated by desert along this line.
Pretty much. Then it crosses the Red Sea.
And into the Middle East.
Right. Saudi Arabia is next, passing not too far from major holy sites and cities like Al-Madinah and Mecca and near Riyadh. Then it clips the UAE, just the Abu Dhabi Emirate, before crossing Oman, including right through its capital, Muscat. Still largely arid, but getting coastal influences.
Okay. Then it hits the Arabian Sea, and after that, Asia.
Big time. It enters India in Gujarat and then cuts across a huge swath of the country: Rajasthan, Madhya Pradesh, Chhattisgarh, Jharkhand, West Bengal, Tripura, Mizoram.
Wow, that's a lot of India. Very diverse regions, too.
Absolutely. Then it goes through Bangladesh, hitting Khulna, Dhaka, and Chittagong divisions, then into Myanmar. After that, it slices through southern China.
Which parts of China?
The provinces of Yunnan, Guangxi, and Guangdong. Interestingly, it passes only about 7 kilometers north of China's border with Vietnam at one point.
Close call.
Yeah. Then it crosses the Taiwan Strait and hits Taiwan itself, places like Hujing Island, Chiayi County, Hualien County.
So a massive contrast already. deserts, densely populated plains, mountains. What's next? Open ocean.
A lot of it. It crosses the Philippine Sea, passing just south of Necker Island, which is part of Hawaii, way out there.
Hawaii. Near the tropic, but not quite on it.
Right. Then it's the vast expanse of the Pacific Ocean before it makes landfall again in North America.
Which is Mexico, right?
Yep. It comes ashore in Baja California Sur, crosses the Gulf of California, and then cuts across mainland Mexico states like Sinaloa, Durango, Zacatecas, San Luis Potosí, Nuevo León, and Tamaulipas. Again, really varied terrain.
Deserts, mountains, maybe some more humid areas towards the coast.
Exactly. Then it crosses the Gulf of Mexico, passing just north of Cuba.
So close to Cuba, but misses it.
Just misses it. Then into the Atlantic Ocean proper. It threads through the Straits of Florida, the Nicholas Channel, just south of the Anguilla Cays in the Bahamas, through the Santarin Channel.
Sounds like tricky navigation.
Must be. And then it cuts right through the Bahamas themselves, the Exuma Islands, and Long Island. Finally, it's across the open Atlantic back towards Africa and the Prime Meridian.
What a journey. It really underscores the incredible diversity of environments and cultures packed along that single line of latitude.
Doesn't it? From emptiness to massive cities, deserts to islands.
And then you mentioned a lot of deserts, especially in Africa and the Middle East. So is the general climate along the tropic just hot and dry? Is that the rule?
That's definitely the dominant theme, you could say. Hot and dry is a very common climate pattern along or near the Tropic of Cancer. The Sahara is the prime example, covering a huge portion of its path.
But I feel a but coming. There must be exceptions.
You know it. The Earth is rarely that simple. There are some really striking exceptions to that hot and dry rule.
Like what?
Well, for instance, you get much cooler climates in some of the highland regions it crosses, like parts of China. Altitude makes a huge difference.
Okay. Elevation cooling things down. Makes sense.
And then you have the marine environments, like near Hawaii. Even though it's tropical latitude, being surrounded by ocean moderates the temperature significantly compared to the continental deserts.
Right. The ocean effect.
And then maybe the most dramatic exception, some easterly coastal areas get absolutely drenched with rain.
Drenched. How much are we talking?
We're talking about orographic rainfall. That's rain caused by mountains forcing moist air from the ocean upwards.
Oh, okay.
In some spots, particularly in Asia, this process can dump unbelievable amounts of rain, sometimes reaching up to 4 meters. That's about 160 inches annually.
4 meters of rain. That's insane, especially compared to the Sahara nearby, relatively speaking.
It's an incredible contrast, isn't it? Shows how topography and wind patterns can completely override the general latitudinal climate expectation.
So definitely not uniform. What about seasons? Is it just hot year-round or...?
Most places along the tropic tend to have 2 main seasons. You get a really, really hot summer. Temperatures can easily hit 45 degrees Celsius, which is 113 Fahrenheit. Super hot. And then you get a warm winter. It's not cold. Usually maxima are around 22 Celsius, maybe 72 Fahrenheit. Still very pleasant.
Okay, hot summer, warm winter.
But then further east, particularly in places like India, Southeast Asia, southern China, you get the monsoon influence.
The monsoon.
Yeah, so it's more of a torrid monsoonal climate. That means a distinct, short, very intense wet season, usually June to September, and then the rest of the year is much drier.
So different patterns depending where you are along the line. This leads me to something that sounds completely contradictory. You mentioned highlands.
Yeah.
But glaciers.
Yeah.
Is it even possible for glaciers to exist anywhere near the Tropic of Cancer with all this heat we're talking about?
It sounds impossible, doesn't it? Glaciers and tropics in the same breath.
It really does.
But, incredibly, yes, altitude is the key. Think about the highest mountain that's right on or very close to the tropic. That's Yushan, or Jade Mountain, in Taiwan.
Okay, Taiwan. High mountain.
Very high. And during the last major ice age, the last glacial maximum Yushan actually had glaciers that reached down to about 2,800 meters elevation.
Wow. So glaciers on the tropic, historically at least.
Historically, yes. And even today, while maybe not precisely on the line itself, there are still glaciers surprisingly close by.
Really? Where?
Well, just north of the tropic, you have glaciers in the Himalayas, like Mingyong and Baishui. And to the south of the tropic, in Mexico, you have glaciers on Pico de Orizaba, that huge volcano.
Pico de Orizaba, right. I've heard of that.
So even though it's technically within tropical or subtropical latitudes, the extreme altitude allows permanent ice to exist relatively nearby. It really messes with our simple idea of what tropical means.
That's a fantastic counterintuitive point. Glaciers near the tropics. Okay, so Beyond the physical geography and climate, does this line have, I don't know, bigger impacts on human systems, politics, anything like that?
It does. Surprisingly, you wouldn't think an imaginary line could matter that much in, say, geopolitics, but it does.
How so?
One of the most concrete examples is NATO, the North Atlantic Treaty Organization.
Okay, the Defense Alliance.
The Tropic of Cancer actually marks the southern boundary for NATO's mutual defense commitment.
Wait, seriously? The Defense Pact stops at the Tropic of Cancer?
Essentially, yes. Article 6 of the North Atlantic Treaty defines the area covered. While it's been interpreted slightly differently over time, especially regarding islands, the core treaty text references the Tropic of Cancer as a southern limit for an armed attack on member territory that would trigger the Collective Defense Clause.
That's incredible. So an attack on a NATO member's territory south of that line wouldn't automatically trigger Article 5, the all-for-one clause.
That's the general understanding. It's a really clear example of how a geographical line, chosen likely for cartographic convenience long ago, has embedded itself into major international agreements and strategic calculations.
Mind blown again. Okay, what else? Any other surprising impacts?
Well, aviation record-keeping uses it as a benchmark.
Aviation. How?
According to the FAI, that's the Fédération Aéronautique Internationale, the World Air Sports Federation, if you want to set an official round-the-world speed record in an aircraft, your flight path has to cover a distance that's at least as long as the circumference of the Earth measured along the Tropic of Cancer.
No way. They use the tropic's length as the minimum distance.
Exactly. That length is specifically calculated as 36,788 kilometers, or about 22,859 miles. You also have to cross all meridians and end up back where you started.
So it's not just flying around the equator or something simpler.
Nope. For the speed record, the Tropic of Cancer distance is the minimum target. For just a basic non-speed record circumnavigation claim, the rules are a tiny bit looser, requiring at least 36,770 kilometers. But still, the tropic serves as that key reference distance.
That's amazing. A line on a map defining the benchmark for global flight endurance and just bringing it back down to Earth. Can you actually see it anywhere? Are there signs?
Oh, yeah, definitely. People like to mark it. There are physical signs and monuments in quite a few of the countries it crosses.
Like where?
Well, there's one south of Dakhla in Western Sahara, apparently put there by rally participants. It's kind of cool because it's inscribed in both English and Hungarian, oddly enough.
How random.
India has several markers near Mehsana City in Gujarat, in Madhya Pradesh, West Bengal, too, I think. Taiwan has a well-known marker in Rusui Township. China even built a dedicated tower of the Tropic of Cancer near Guangzhou.
The tower? Okay, they take it seriously.
They do. So yeah, you can physically go and stand on the line, or at least where a sign says the line is, remembering that it might have drifted a bit since the sign went up.
Right. Got to account for the drift. Well, this has been quite the journey. It's clear the Tropic of Cancer is so much more than just, a line we learned in school.
Absolutely. It's this dynamic feature deeply connected to astronomy, history, climate, geography, even politics, and human achievement.
It really ties together the planet's mechanics with our experience on the surface, full of those unexpected twists like outdated names and nearby glaciers.
It's a great lens through which to see those connections.
So, thinking about all this, if a line we consider so fundamental, so defining, like the Tropic of Cancer, isn't actually fixed but is constantly drifting, and even its name is sort of a historical echo, what does that make us think about other things we consider stable? Other boundaries, concepts, maybe even definitions in our world that seem permanent. Could they also be in this state of subtle, constant flux underneath? It kind of invites you to look a bit closer, doesn't it? To question what seems fixed.
It really does. A reminder that the ground beneath our feet and the lines we draw on it are perhaps more fluid than we often assume.